All right, so what we're going to take a look at is how to draw a heating and cooling curve. So first off, we have to have our axes. All right, and on this side over here is going to go the temperature. And down here you can think of this kind of like time or the amount of energy that we're putting into a system. So energy or time. So we already know before that when we go from, say, a solid to a liquid, if we have a block of ice and we let it sit out on the counter, all of a sudden when it hits past that melting point at 0 degrees Celsius, it doesn't suddenly become a puddle of water. There's some time or there's some more energy that has to happen when we put into that. So the first thing that you want to do is you want to start out down here in the corner and make an increasing line. This is for a heating curve. And then we have a horizontal line. We have another increase in temperature, and then we have another line, and then we have this that goes like this. This right here is a heating curve. I'll label it at the top as heating curve because I'll show you how to do a cooling curve in a second. So what are our three main states of matter? We have solid, liquid, gas. So the first thing that you want to do when you come across a heating and cooling curve on any of your work is go ahead and make sure that you label this solid, liquid, gas. And all of that solid, liquid, gas are all of the ones that are diagonal lines, or all the ones that are increasing diagonal lines. And we know because they're increasing that this is a heating curve. Now, what is the point right here? What is this point that we're going from a solid to a liquid? Well, as we continue to increase in temperature or increase in time, that we know that we're going to go from a solid to a liquid, that this is called the melting point. So this right here is a melting point. You'll notice that the temperature remains the same. The temperature is still going to be the same, but the molecules, remember, are moving around and they're rearranging themselves. So now we have our liquid. So once we get to this point, we get over here, we get an increase in temperature. Our liquid is doing this, it's all heated up, and then eventually it's going to turn into a gas. And the point right here at which it turns into a gas, that right there is our boiling point. So we're going to go ahead and mark that as our boiling point, and then we have gas that's above that. Now, this is our standard right here. This is our standard heating curve. Now, if we were to do this for, say, H2O, all right, H2O. Let me go ahead and switch colors here, and let's do that for liquid H2O. As a solid, we know that that is called ice, and the point right here at which it changes into liquid water is going to be 0 degrees Celsius. And right here, we know the point at which it goes from water to water vapor is going to be 100 degrees Celsius. So that is where our temperature lines are. So as long as you're able to show that this right here, this line is equivalent to whatever temperature the actual boiling point is, or down here for the melting point, then you're in good shape. Now, another thing that I want to address while we're already here, I'll go ahead and make this one yellow, is that this point right here is really where evaporation begins. So evaporation and boiling point are the changes from a liquid into a gas, but it's really hard to determine that in terms of being able to break it out on this graph. What you want to know is that at the start, it's enough energy to get the molecules going from a liquid to have one kind of pop off here and there. It's enough energy at the surface for them to be able to go, which is another reason why your skin is not 100 degrees Celsius on fire, right? When you're sweating and though it evaporates off of you. By the time that you get over here at the end, you have this roaring pot that you're boiling for some type of pasta or something of that nature. So this is a heating curve. I'm going to stop this video and then show you a cooling curve in the next one so that I have time.